uh, where we were, right? So already the first structure is quite complex. When you supply or provide the heat, it will become more complex, and complexity will reach to that level. It cannot be of reversible nature. That means that cross linking cannot reopen. It cannot be simplified then after. Once it will becomes more complicated. Okay. And in second case, there is no such complications. You will hit it, it will flow down. You will cool it, it will slow down. Okay. It will settle down. Okay. So because of this complex linking, it happens. Okay. So chemical change is irreversible in case of thermosetting, and chemical change is reversible in case of thermoplast. Third one, as we saw, thermosets are having cross-linked polymers, and in case of thermoplast, linear and branched linear polymers. Okay, see it. Thermoplastic, linear polymers. Okay, linear linking, and in case of thermosetting, it is a cross-linking. Cross-linking or complex linking will be there, right? Third, fourth is high load carrying capacity, low load carrying capacity. Okay. Now, now tell me. Okay. So, how to justify that particular sentence? What is the sentence? Higher load carrying capacity in case of thermosetting, and lower load carrying capacity in case of thermoplast. See it. See, if similar kind of load I will apply on both material. Suppose 10 kg, 10 kg load I will apply on the both the structure. This 10 kg will be distributed over this entire structure, and if you find it, there are so many linkings are there. So that linking will distribute load to the more number of monomers. So per atom load will be less. Per atom load will be less. See, in case of thermosetting, so many intermediate bonds are there. Okay, that will redistribute the load. But here, per atom or per monomer load is going to be a more. So obviously, structure is dense, so it will have more load carrying capacity. Okay, don't keep it in mind. You should not require to recall it. Just understand the structure. You should be able to recall the properties automatically. Simple thing. If you give the equal load on the both the material, where there are more supports, where there are more supports, there you can have, or you can manage more load. Okay, so see here, cross linking is there, so distribution of load will be even, or distribution of load will be proper, so that it can withstand more heavy load rather than thermoplastic. Getting the concept? This is happening because of this cross linked polymers. Cross linked polymers. Okay, so first thing, because of cross linking, once you will hit it, it will set down to the hard material. Okay, in case of thermoplast, it will flow, and once you will cool it, it will settle. In case of thermosetting, change is irreversible. In case of thermoplast, change is reversible, right? Then next point is prepared by condensation polymerization in case of thermosetting, and in case of thermoplast, prepared by addition polymerization. Okay, again, condensation means what? A simple definition. You may have seen it through maybe in your applied thermodynamics, right? Condensation means what? If suppose a material is in a liquid state, and once you will condense it, it will come down to its original state, that is in state of the liquid. So vapor will condense to the liquid in the form of droplets. Okay, so so in case of thermosetting plastics, polymerization. Polymerization means what? Again, word polymerization. Just divide the word. Here it is the word where it is polymerization. Okay, poly means multi, and merization. Okay, polymerization means addition of more monomers. Monomers, time being, just keep it in mind. Monomers means an atoms, single units. Okay, so addition of more monomers is nothing but the polymers. Poly means multi, mers means monomers. Okay, So in case of thermosetting plastic, if you have to have the polymerization, you need to follow the condensation method. Condensation method means what? You will have to heat it. Now your question will be, once we are saying that if we heat the material it will harden, then how to go for condensation polymerization? Okay, there is a temperature limit. You may have gone through the concept of critical temperature. The critical temperature is the around 0.4% of the, sorry, 40% of the melting point temperature, right? So critical temperature is that point after which recrystallization starts. And recrystallization start means this structure start reshaping itself. Okay, so you will have to heat below the recrystallization temperature, and through that you will have to go for the condensation polymerization. And in case of thermoplast, a simple addition of monomers, obviously through the chemical reaction. Okay, so that way, in case of thermosetting, condensation polymerization, and in case of thermoplast it will be addition polymerization, right? Now this hard, strong and brittle, soft, weak and less brittle. Okay, again it will come to the structure only. See, more complex will be the structure, it will have more density. More density means it can carry more load, it will be a more strong, heavy, and load carrying capacity will be more. Getting it? Now, in case of thermoplast, if you see there is a very less linking in between, or there is a very less cross linking. So it is a soft, it can flow easily under the action of shear force. Under the action of shear force, it will flow down easily. One layer can be flow down over the another layer. So it is a soft and ductile. Soft and ductile. Okay. And in case of thermosetting plastic, it is a hard, strong, and brittle. Next is the insoluble in organic solvent and soluble in organic solvent. Okay. See, again, insoluble because of this cross linking. See, this more are the linkages. That means there are huge cohesive forces. Cohesive forces means forces of attraction in between two similar atoms. Okay. So because of the huge cohesive forces, these thermosetting plastics are not soluble in organic solvent. Getting it? See, when you will get the solubility, when this bond will break down, but because of the huge cohesive forces and more complex structuring, this is not soluble in organic solvent. But in case of thermoplast, a very simple structure, no any cross linking, so it will easily solve any organic solvent. Okay. Now, see, I have a very good video. It will explain everything in difference between thermosetting plastic and thermoplast. Okay, just keep it in mind, this structure complex here and simple here. Okay, let's see the video, you will get the clear picture. Okay, just see it. Okay, this is, what is this? This is scrubber. Okay, and you have seen it in your shoes. Okay, now here comes the uh, real example, right? Now this is, everyone knows it. Okay, first of all, see what happens with this example. Okay, now just tell me, I have given you the definition of thermoset and thermoplast. Getting it? Thermoset and thermoplast. Now, in case of thermoset, when you will heat it, it will settle down to a hard condition, okay, hard material. And in case of thermoplast, it will melt down, and when you will cool it, you will get hard. It will get hard. Okay. Now you have practically used this concept, or you have gone through it. Particular example. Okay, this is a and egg omelette. Getting it? Okay, you know the initial condition, you know the final condition, right? Have seen it. Initially, it is in a liquid state. Initially, it is in a liquid state. And what physics says, what thermodynamics says, if you supply heat to any material, it will get energized, the bonding will break down, and the material will melt down. Okay, but what happens with it? Check it. Right? Okay, very simple example. What is happening here? A liquid material, when you are heating it, it is becoming more complex. The cross linking or the linkages is becoming more complex, and it is setting in a hardened condition. Okay, finally it will become hard. Finally it will become a hard. Okay. Okay. Okay, this is what contact lenses. Getting it? If you see the material of contact lens, if you see the material of contact lens, if you see it, it can be stretched. On if you heat it, it will stretch. You can stretch it easily. And again, if you cool it, or if you can bring it to the room temperature or some lesser temperature, it will shrink down. Okay, so it can expand, or it can again be compressed to a original condition. Okay, that's how it is designed. Okay, because if so, material will be a very hard material, it will easily harm to your eyes. Getting it? Okay, so it is of that type. If your eyes will expose to the high temperature, that contact lenses are going to expand. Okay, that way these are working. Right. Okay, so here is the example of, what is this example? Thermoset or thermoplast? This is ice cube. This is a solid ice cube. Okay, tell me, will it be a thermoset or it is a thermoplast? Thermoset is heat, it will get hard. Thermoplast is, you will heat it, it will melt down, you will cool it, you will it will settle down. Okay, so ice cube, a simple example. You will heat it, it will convert to the water, liquid state, and you will, if you can cool it, it will again go to the solid state. And cool it down, it will shrink it. Yes. Okay, this is butter. Okay, oh, in one pan there is a butter, and another pan there is a egg omelette that we have made a time before. Getting it? Okay. Okay, now now it is already heated condition, in heating condition. Okay, now tell me, out of this butter will be obviously, what type of it is? This butter, is it a thermoplast or thermoset? Egg omelette we already know, oh, it is a thermoset, because once you will heat it, it will settle down. Okay, but what is this butter? What type of it will? Is it a thermoset or thermoplast? Again, thermoplast, right? So because simple, as like ice cube, you will heat it, it will melt down. You will cool it, it will shrink down. Now, Just come here. There was one line here. Chemical change due to heating is irreversible. Second. And here, chemical change is reversible. Chemical change is reversible. See, this shrinking, melting is nothing but it's a chemical change. It's a chemical change. Okay. Now, tell me, we have an example of egg omelette in case of thermosetting plastic. We have an example of egg omelette in case of thermosetting plastic and butter or ice cube in case of thermoplast. Now, I'm saying here chemical change is irreversible, and here I am changing saying chemical change is reversible. Why? You can see it here. You can see it here. If you see it, if I will again heat this particular thermoset, this egg omelette, I will supply again extra amount of heat. What will happen with this particular egg omelette? It will burn down. It will start appearing in a black color. Is it possible to melt it down again? This egg omelette, can it be possible to melt it down? Supply as much quantity of as heat you may possible to supply. Okay, if you try to supply maximum quantity of heat, if you try it, you will find that it will simply burn down, and at the end you will get a powder like structure in your hand, but you will never get a liquid structure, because at the start it was a liquid. At the start it was a liquid, then because of heat it became a solid. Now, can we convert this solid into liquid once again? No. By any condition, we cannot change it into original condition. So this is called as a chemical change is irreversible. Chemical change is irreversible. Just you hit it again. What will happen? See it. Burn down. It will burn down. Okay. Got it. Okay. So this happens. This happens so that in case of thermoset, chemical change is irreversible. And in case of thermoplast, see it. You just heat it, it will start vaporizing. You just cool it, again it will come to the liquid state. Again cool it, it will come to the solid state. So in case of thermoplastic, chemical change is reversible. In case of thermoset, chemical change is irreversible. Okay. So whenever you will have any type of question based on thermosetting and thermoplastic, these examples should come into your mind, and you will have to write based on these examples. Okay. Thermoset, egg omelette, thermoplastic, ice cube, or butter. What else next? Let's see. Okay, see, this happens in case of thermosetting. Right? There is a cross linking. Yeah, it flows like thermoplastic. These are some examples. Here also. Here also. Okay, now two examples are in front of you. One is carry bag, which we call chemical name is polyethylene. Polyethylene. Okay, polyethylene. So it is a long chain of ethylene monomers. Ethylene monomers, when it is combined together, it is called as a polyethylene. Okay, it is again polymerization process. Okay, so one example is carry bag, that is polyethylene. Another example is a tire. Okay, so tell me, out of this, which is thermoset and which is thermoplast? Let's take first one, carry bag or the polyethylene. What is that, thermoset or thermoplast? What will be your answer? The first is carry bag. Is it a thermoset or thermoplast? Polyethylene, thermoplast. Okay, right? So you melt it, it will, you just heat it, it will melt down. This can be recycled. By the way, these tires uh, are falling into the group of thermosets. Okay, thermoset. So these tires are not recyclable. Okay, because what we have seen, chemical change is irreversible. So whatever these tubes and tires are, these are not reusable type. Okay. So what they are doing with the tubes and tires? These tubes and tire, there is a process of cracking. Okay. So from these tubes and tire, a diesel like oil is made. Okay. If you want to see the unit, just nearby our Mangalwada, there is a unit for converting these tubes and tires into a diesel like oil. Okay. And this diesel like oil is then after used in, not for transportation purpose, but it is used in like NTPC, right, for heating purpose. Okay, so that way it is used, so it is then converted into the oil, but it is not recyclable because of thermosetting type nature. Getting it? So simple example, egg omelette and ice cube, right? One more is there, PVC pipes. Okay, now in your village or in agricultural, these PVC pipes are used. PVC pipes. Okay, now you have seen your agriculture or in your village also, when you are joining the PVC pipes, generally there is a socket to join two PVC pipe face to face. Okay, sockets are there, but if suppose this pipe will break down in between, because end to end there are sockets, large size sockets. Okay, you can easily uh, join it, but one, if the pipe will break down in between, if there is some leakage will be there in between the pipe, so that time you just what is the practice, cut down that particular part. And how they are doing it, you have seen it in a village. Okay, in your farm, they are heating that pipe, they are hitting that pipe, immediately another part of pipe or the face of the pipe is inserted into that by moving it inside that heated region. So it will size of that particular thing will be more, and immediately you are pouring the water on that. What is happening? Again, first point comes, heat causes them to soften and cooling causes them to hard. Getting it? PVC pipes, if you heat that, it will become soft, so you can enlarge that, accommodate the next phase of the pipe in that, and pour the water, it will cool down, it will shrink down, and it will hold it tightly. Getting it? So PVC will come under the thermoplast. PVC will come under the thermoplast. Okay. So got it. So everything, this difference came from this structure. Difference come from this structure. Okay. First thing, heat causes them to set and hard. Second, heat causes them to soften uh, hard once it will cooled. Okay. In case of thermosetting, irreversible chemical change. Here, reversible chemical change. Then high load carrying capacity because of complex structure, lower load carrying capacity because of less linkages, hard, strong, and brittle. Okay, again, again. Whenever material is too hard, it is brittle. Whenever material is soft, it is ductile. Okay, ductile or less brittle. Getting it? This is the metallurgical concept. You know it. Okay, whenever material is too hard, it is of brittle nature. Whenever material is soft, it is of a ductile nature or the less brittle nature. And second, last, insoluble in organic solvent because of complex linking, and in case of thermoplast, it is soluble in a organic solvent. Okay, so these are the major differences between the thermosetting plastic and thermoplast. Simple structure, complex in case of thermosetting, and without any complex linking, it will be with the thermoplast. Getting it? Right? So, so these are the basic difference points between the thermosetting plastic and thermoplast. Okay, it is mostly, it will be asked in your final year exam also, and in any other exam. Generally, whenever the question will be there from the plastic, here this is going to be the point. Okay, obviously at the time of interview also, if your topic will be that one. Now, the next point will be a properties of plastic. Properties of plastic. Okay, so this slide I have kept intentionally first of all blank. Okay, because I know I need answers from you. I'll take one by one property and you will have to answer it. Okay, now the first one, density. The first one will be density. So answer me, will the plastic will have less density or more density? The first question, if I want to describe with respect to density of the plastic, what will be your statement? Will it be have less density or more density? Okay, just a minute. Okay, so it will have less density. Okay, so we'll summarize it. Okay, now answer it fast. What about the density? It will have lower density. Okay, now I need the fast answers. Okay, I agree. Yeah, density will be less, right? So first of all, what is mean by density? What is mean by density? Answer fast. What is the density? What is the meaning of density? Mass per unit volume. Mass per unit volume. Okay, it will be called as a density. Okay, and what is weight density? Next question. Now again, we are going deeper, slightly different, but you will get concept easily. Okay, you are told that you told that it is a mass per volume, a simple definition of density, mass per volume. Okay, what is weight density? If I am not wrong, mass per volume is the mass density. Okay, and the weight per volume is the weight density. How you will get it? If I have mass density and I want the weight density, okay, 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 multiplied by g, acceleration due to gravity. So it will be a weight density. It will be a weight density. If I will reverse it, you have said it mass per volume. If I will say it volume per mass, volume per mass, what it is called? Mass per volume is okay, great. Specific volume, okay. Whenever we are defining anything with respect to unit quantity, it will be called as a specific volume per unit mass. Volume per unit mass, it will be a specific volume. It will be a specific volume. That's great. Okay, now we'll go again ahead. Okay, I have told at the start of our plastic engineering only that whenever we'll get chance to go deeper, more and more deeper, we will go. Because see, if suppose there will be an interview in your ISRO or BRC or TRDO, such type of basic questions are asked. If suppose you will say that your favorite subject is the plastic engineering, so they will not directly ask you differentiate between the thermoset and thermoplast. Easy, anyone can answer it. They will go to this much of level. They will go to the basic level. Okay, so we'll also go somewhat to basic level. Okay, you are clear with the mass density, weight density, specific volume, no problem, right? Now, now, you know the density of the water. Okay, well, in the last lecture we have seen it 1000 kg per meter cube, 1000 kg per meter cube. Now, if suppose I will put uh, solid material or solid atom in the water, okay, if I will put some solid material in the water, which criteria will define that it will either sink down or it will float on the water? Getting my concept? Getting my question? If I will put some solid material in the water surface, on the water surface, what criteria will decide that it will sink down or it will float? If density is more than liquid, it will sink down, and if density is less than liquid, it will float. Okay, obvious answer. Okay, so that if you have suppose a petrol, you may have seen that there is a many time leakages from the oil tankers in the sea. Okay, whenever there is a leakages from oil tankers in the sea, this petrol mostly floats on the water surface, because the density of the petrol or diesel is less than the density of water. Density of water is 1000 kg per meter cube, and density of petrol is around 850, average 850 kg per meter cube. So it is lesser, so it will float on the water surface. So any oil, any other liquid which is having less density than the water, it will float on the water surface. If suppose the density is more, if suppose the density is more, like mercury, okay, mercury, a huge density, if you see the mercury, okay, so it will not float on the water. Getting it? Okay. Now now again, one more question. I have a material, solid material, whose density is more than water, whose density is more than water, but I want that material should float on the water, as like large ship, as like large ship. Material used is steel or copper or wood, whatever it may be. Its density is more than water, still it is floating on the water. Answer. You told me at the start, if density is lesser, if density is lesser, it will float on the water. Now I am saying that I'm the see the ship. Suppose ship is made from, obviously it is not made from a plastic material. Okay, it will be made from the maybe a steel whose density is more than the water. Okay, but ship is floating on the water. Answer me. Concept says that if density is less, it will float. If it is more, it will sink. But here density is more, but still it is floating on the surface of water. The reason, area of contact is more. In technical language, how you will say? Area of contact is more. Okay, in one way it's okay, but it technically answer. I want the technical answer. Density of the material is more than water. Density of material is more than water. Okay, stuck down. Okay, one concept is there, buoyancy force. Buoyancy force. Okay, okay, okay. You are close to that, but I want exact answer. Okay, no problem. You are trying. That's great. Okay, just see it. A simple example. Simple example. A spherical ball made from the steel material or MS, mild steel or iron. A spherical ball made from the iron. A simple spherical ball. If I will drop it in a sea, if I will drop it in a surface of on the surface of water, it will sink down. Agreed. Spherical ball made from copper or iron or steel. If I will put it on the surface of water, it will sink down, right? But a spheric, a plate of, a plate, right, right. A plate made from the steel or copper, if I will put it on the surface of water, it may sink down or it may float on the water. But I will 100% sure that a spherical ball of steel will sink down. The reason behind is that yes, density is a one concept, but another one thing is that if if weight of the water, if weight of the water that get displaced, if weight of the water that get displaced because of the material kept on the water, if that weight of the water displaced is equal to weight of the object which you have kept on the surface, if that weight of object is equal to weight of water that is displaced, then if that are equal, then it will float on the water. Got the meaning? Got the meaning? Whatever weight of the water that has been displaced, it should be equal to weight of the material. Material will float on the water. What is happening in case of steel ball? volume of the ball is very less, and material displaced because of that spherical ball, sorry, weight of the water that is displaced because of spherical ball is very less as compared to the weight of the spherical ball, so it will sink down. But when there is a spherical, sorry, when there is a steel plate, because of large area, it will displace large quantity of water. So that quantity of water, if its weight is equal to weight of steel plate, the plate will float. The plate will float. So it depends upon weight of the water displayed, sorry, displaced, and the weight of the material. Weight of the material. Getting it? Archimedes principle. Great, 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 great. Right? So density is the one part, and this is another concept. Are you getting the things, or am I just diverting you all to the another path? Will it be okay, or shall I stick to the content only? Okay, that also we can do, right? But see, understanding is important rather than just book uh, bookish knowledge. Okay, so have you got this concept? A simple concept: weight of the water displaced must be equal to weight of the material. Okay, that's simple and easy. Okay, got it? Shall I move ahead? Need the response. Okay, 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 okay. ठीक है. So the first part, density. Density of the plastic is less. Density of the plastic is less. Agreed. Second, what about the melting point? What about the melting point? Okay, you will have to answer. Okay, I will not directly show you the properties. What about your opinion about the melting point of plastic? Will it be a less? Will it be a more? Melting point of plastic. Melting point of plastic. Okay, less. Simple concept. There is no any complex type of structure, so it will have a very less melting point. Okay, it will have a very less melting point. Now, okay, that is obvious. You can easily answer that. What I want, if you compare thermoset and thermoplast, if you compare thermoset and thermoplast, which will have less melting point? If you compare thermoset and thermoplast, which will have less melting point? Compare here. Answer it from here. Which will have less melting point? Right, right, right. Okay, thermoplast. Because see, if you want to melt this thermosetting plastic, you need to have more heat because of this linking, because of this cross linking. See, melting means what? Breaking of this cross linking, breaking of this bond. If you want to break that many number of bonds, you need that much of quantity of heat. Okay, so obviously melting point of plastic is low, but out of that thermoplastic will have lowest melting point, and thermosetting will have more melting point. Okay, now, okay, just a minute. Okay, what I told, thermoset is having thermoset is having more melting point. More in the sense here, and thermoplast is having less melting point. Based on this, based on this, okay, based on this, thermoset is having more melting point, and thermoplast is having less melting point. POINT. Based on this two statement, can you tell me this material, this component, what will be material of this, thermoset or thermoplast? It is a frying pan. It is a frying pan. Frying pan. Okay, what you told just now, thermoset will have more melting point, thermoplast will have less melting point. So this frying pan, from which material it should be manufactured? Thermosetting plastic or thermoplastic? Thermoplast. Got it? Got it? Okay. That's how you should be able to just make this linking. Okay. Properties with respect to applications. So you can check here. PVC. We require very less amount of heat to melt it down. It comes under the thermoplast. Okay. So melting point, that's okay. Okay. So now I will show it you some properties. So first, comparatively low density, agreed. Good mechanical strength. Okay. Again, you may have the question here. How we can prove that plastic will have the good mechanical strength? Obviously, a pure plastic will not have good mechanical strength, but when it will have reinforcement in terms of the fibers, that will be called as the plastic composites. Okay. Obviously, you will get a good mechanical strength. Okay. Good flowability in mold. You know this concept you may have studied this in terms of casting also. Okay. See, if the melting point is less, the material will have good flowability. Flowability means what? It can easily flow. It can easily flow. So can I say from this property that when you want complex parts, when you want to manufacture complex parts, then plastic is the best because of this flowability. Because of this flowability, low melting point, plastic materials can be obtained in low processing time. Because see, low melting points means easily you can melt in a very fast. Good flowability, so it can accommodate mold in a very short time. So short time for melting, short time for mold, obviously the low processing time, it may result into low processing time. Components can be manufactured in wide variety of dimensions because of good flowability. Because of good flowability, any type of components, so that toys are mostly manufactured from the plastic. Okay. Good damping capacity. What is meant by damping? Damping is the vibration absorption capacity. Okay. Vibrations are nothing but the cyclic stress. Cyclic in the sense sometimes tension, sometimes compression. Okay. That type of stress. Okay. So it is having good damping capacity, better heat and electrical insulating properties. Better heat and electrical insulating properties. Okay. So that the plastic is used, if you have seen your electrical cables, it is having a covering of plastic. Okay. Electrical switches, electrical boards. Okay. Whenever you will see, it is made from the plastic because of this heat and good quality of, sorry, better heat and electrical insulating properties and good chemical stability. Okay. uh, right. See, whenever there is a ferrous based materials, this chemical stability becomes an issue. Chemical stability becomes an issue because chemical immediately react with the ferrous materials. But in case of plastic, it is having good chemical stability, so it will not immediately react with the chemicals. So most uh, probably in case of chemical industries, the products are made from the steels, no problem. But inside sheathing, inside coating is made from the plastic. See, because a pure plastic cannot give more strength. Okay, pure plastic cannot give more strength. Here it is written, but that is composite plastic, and the cost of composite plastic is quite higher. So better way, go with the steel product and have a coating of plastic. Okay, that will have a good, because plastic is having good chemical stability, right? So I think that's it for today. So what we have completed today, the basic major important point, thermosetting and thermoplast. Keep it in mind. Two examples: egg omelette, ice cube. Okay, that will enough to explain everything. Okay, two three things you need to keep it in mind: irreversible change, cross-linked polymers, linear polymers, higher load carrying capacity, lower load carrying capacity, hard strong brittle, soft weak and less brittle, insoluble and soluble. Okay, and this is the structure, right? And the basic common properties. properties with respect to density, strength, flowability, melting point, processing time, variety of products, damping capacity, resistance power, and chemical stability. Okay, so we are done with the classification. Do not need You need not to go more deep about this natural, semi-synthetic, and synthetic, but you need to understand properly about this thermosetting and thermoplast. Okay, because this is asked mostly, and the properties of the plastic, the common properties, basic. You can easily write that. Okay, so that's it for today. If you are having any query, you can just text me. You can call me. Right, I'll answer it. So wait. Take the attendance. Okay, stop the recording.